Okay. For this part, actually, there are three classes of the B2C products, B2C chemical product, meaning that business to consumer chemical products, B2C. Okay, this is the ends of the design. Okay, not B2B. Okay. Which is we can divide into devices, functional product, and also formulated products. Okay, so you have to remember devices, functional product, and formulated product. The main things, for today's the main things that we want to differentiate this type of products and also the examples. Okay, so overview of this part. Okay, we will cover first introduction, product specification, mathematical modelings, and also element of the product design frameworks. I think if possible, we will cover. I'm not sure until here or not. Okay, all these things we will cover on it. Okay, and then part two, how can we design the chemical devices and functional products? Okay, based on the mathematical modelings. If you still remember, what is it? The kinetics. Okay, the flux ratio. That is the mathematical modelings. Okay. So you have to remember in terms of the mathematics are the considerations. Okay, what else? Uh, uh, in terms of fluid equations, right? Okay, viscosity, Fourier's law, Fick's law. That one is we need that mathematical modeling to design your chemical devices and also functional product. Okay, and then part three is we are focusing on the formulated products. Okay. This one is, for example, like a sunscreen lotions, okay, insect repellent spray, and also cream. Okay. Okay. So for today is introductions, okay, product specification, mathematical modeling, and elements of the product design frameworks, if possible. Okay. And as outcomes, I hope that you can know the characteristic of the, what is it? You can recognize the characteristics of the devices, functional product, and also promoted products, and familiar with the procedure, method, and tools for the conceptual design of these products. You can design the chemical devices, functional product, and also formulated products. That one is a outcome for number 4. Okay. Okay. So B2C products, right? Okay. Classes of the chemical products. Okay. B2C products like lotions. Okay. Toothpaste. What else? Mosquito repellents. Okay. Water purifier, air purifier. Okay. Actually, is they have a different structure. Form, okay, shape, and also configuration. Okay. So and most of like device and functional product, right? They made from the multiple components, right? Okay. In order to get this device and also functional products, okay. So we can classify in general or in a wide variety of the products. Okay. They have a three major classes. We call it as a chemical devices. Okay. Functional products and also formulated products. Okay. Okay. So let's see the chemical devices. Okay. If you look at here, chemical devices actually chemical product that can perform a particular purpose. Okay. Especially those with the mechanical and electrical part. Okay. The main things that we can differentiate with the other class of the products. Okay. For the chemical device should have feed stream and outlet stream. Okay, that is the difference. Okay, which is a feed streams of the chemical devices we transform into the outlet stream. Okay, there is in and out, like the water purifier, there is in and out, right? Okay, this is the main characteristic. Okay, these characteristics specified in the product attributes by the performing reaction. Okay, fluid flow, heating, cooling, and or separation. Okay, so we can view a chemical device. Actually, we can view as a miniature chemical process equipment. This is a small okay, small like what is it? Like mosquito repellents. That is miniature. Okay, But if a huge one, like a chemical plant, that is a huge one. Okay, or interconnected equipment items. Okay, so you can be viewed in terms of three groups. Okay, miniature, interconnected equipment items, and also chemical plants. Okay, so for the chemical devices, actually comprised of different materials. Okay, uh, configured with the customized structure, form, shape, right? For the chemical plants, if you look at here, they have what is it? The reactor, okay, distillation column, crystallizer, separator, filter, absorber. That one is in terms of chemical plant. How can we differentiate between the chemical device and also chemical plant? Okay. So what is the chemical? What is the example of chemical devices? Okay. So if you look at here, this is the example, the reverse osmosis module. Okay, so we want to what is it? To clean the water. Okay, the outlet is the clean water, filtered water. Okay, so if you look at here, that this is a spiral wound of the with the multiple RO membrane. Okay, we can see here, right? And this one, there's a spiral, right? Okay, and the feed is flow, right, between the two RO membranes. Okay, this is separated by the permeable feed spacer. This one, right? Feed spacer, right? This one. Okay, and the clean one is gonna be as outlet. This one is clean, and retentate. This one is the what is it? Contaminant molecules. Okay, so they have a feed and also outlet, but this one have two outlet. Uh, they have this one is the what is it? The dirty one. Okay, the contaminant. Okay, so this is the purpose is to filter water free from contaminant. Similarly, also for the water filter. This one is from the tap water. Okay, if you look at here, they use the what is it? The activated carbons. Okay, we want to remove the metal ions by using ion exchange resins from the water. This one I think is not very expensive. About five ringgit, so you can find as a Eco Shop or Daiso. Okay. Okay. So another example is a wine aerator that suck in air into the passing wine to soften the tannins in the red wine. Okay. Actually, is by using the by direction and also stripping process. Okay. Another example is a mosquito repellent. Okay. This one we leave the solvents. Okay. So we heat the solvent, right? So that the what is it? The volatiles will repel the mosquito. Okay. So this is the concept. Okay. So you can hear that vaporizing the active ingredients to repel the mosquito. So meaning that like a solvent. Okay. So for another example is like a hemodialysis devices. Okay, we want to remove the contaminants, unwanted metabolites from the bloods. That is another example of the chemical devices. Okay. Okay. That is a chemical devices. Okay. How about the functional products? Okay. For the functional products, if you look at here, that we use as a barrier actually for the packaging. Okay. Or conductor. Okay. And also we use as a delivery lah. Okay, delivery vehicles. Okay, so if you look at here, the difference between the chemical devices and the functional products, okay, they do not have feed and outlet streams. You have to remember this one. Do not have feed and outlet stream and do not involve mechanical and electrical parts. For example, this one, right? Food packaging. There's a no electrical part or mechanical, right? Okay, and this one is just to filter the what is it? Particles or something unwanted compound uh, in air, right? So this is not involved the what is it in inlet or outlet streams. Okay, absorber. Okay, absorber is like a silica gel. We want to remove the moisture, absorb the moisture. Okay, And the performance of the actually this one is similar like what is it, the chemical device. The performance of the functional products depends on the material properties, okay, structure, form, shape, and also configuration. This is only this is similar like the chemical devices, okay. So this is important. Only the difference here, this one, okay. You should know this, the difference between chemical devices and also functional products, okay. Okay, let's see the examples. Okay, for example, it's like what is it? Moisture absorber, right? Using silica gels. Okay, this one we want to reduce the humidity. Okay, or also oxygen absorber, right? Okay, we don't want the oxidation occur. Okay, so this one we can put in the closed cabinet, or sometimes what else? In the food packaging, right? Okay, so we can use also. Okay, another one is a food packaging. Okay, using metallized polyethylene. Okay, this is we want to prevent the oxygens. Actually, if you look at here, the packaging, they have a 3 layers. Okay, outside generally we use to for the this one brand. Okay, we can write the names. Okay, inside is the barrier layer. Okay, this one is that's why you see the inside barrier is like how to say, silver color, right? The inside barrier. Okay. Okay, and then the next one is the what is it? Functional products. This is granules to control herbicide. Okay, control this herbicide granules. Okay, this is along the maybe is along with the times, or prolong period of the times. Okay, so this one is another example. Okay, what else? Like PET bottles, right? Okay, so high barrier of the PET bottles. Okay, so that one is also another type of the functional products. Okay, pharmaceutical capsules. Okay, transdermal patch, we call it also handy plus. Okay, that one is we can use we can use to deliver an active pharmaceutical ingredients through your skin, right? Okay, so that is all the example of the functional products. Okay. Okay, so we already see the example of the functional and chemical device. What is the difference? Okay, so let's see the formulated products. Okay, for the formulated products, okay, if you look at here, that the we can obtain by mixing selected component together to get the desired product attributes. Okay, for example, like a sunscreen lotion, right? Okay, maybe consists of the zinc oxide particles or active ingredients like emollients. Okay, that is another example. Or inkjet printer. Okay, they have a pigments of a nanoparticle, metal nanoparticles. Okay, so what else? Like a liquid shampoo. Okay, have a fragrance, colorants. Okay, is the mixing of the component together. Okay, for this one is a many products such as antifreeze do not possess a microstructure, but some such as skincare lotion. Okay, the lotion can be oil in water or water in oil emulsion with the different emulsion droplet size. So in to design this formulated product, this it is important to see the ratio between oil and also water. Okay. So if you look at here, that formulated products, the difference between the what is it? Functional product and also chemical device, they do not involve reaction or separation. Okay, this one, especially with the chemical device, right? Chemical device, they have separation, okay, or reaction. Okay, okay. So that is the important thing, the difference, and also it's actually is a mixing. Okay, the most easiest example is like lotions, right? Detergent, skincare creams, paint, inkjet printer, adhesive. This one is formulated. It's just a mixing of the compound. Okay. Any question about the differences or definition of the formulated functional product and also chemical devices? Any questions? Okay, I hope it is clear. Okay. Okay, so let's see the product specification and as a summary, okay, between the devices, functional, and also formulated products. Okay, so if you look at here, for all the three products, okay, devices, functional, and formulated products, okay, chemical engineers are responsible for designing a product that meets the product specification. Okay, if you look at here that for the device, okay, the product specification should include types and the amount of the ingredients, okay, and the structure with which the ingredients are configured. Okay, for example, if you want to develop the prototype of the air purifier, right? So you need the catalyst, like a titanium oxide. So what is the amount of the catalyst? Okay, and where you want to put the catalyst, where you want to place that catalyst, okay, in the air purifier. Okay, so you have to know when you want to design this air purifier. Okay. Okay, so for the functional products, okay, so which is absent of mechanical and electrical parts and also feed or outlet streams. So this one is should be different with the devices. And also the product from the formulated products, okay, the product characteristics, the specifications are the composition of the mixture and the microstructure. So meaning that mixing of the compounds. Okay, so this is the importance. If you look at here that the modelings, okay, is the key technique in the product conceptualization and also specification. Okay, so before we do we test to the consumer, okay, we have to do the modeling, because we want to know the is it can be applied in real life or not. Okay, so product specification is important. Okay, so what is the difference actually between the product design and also product analysis? Okay, if you look at here that for the product analysis, we know the input. Okay, we know the input. Okay, type, amount, ingredients. Okay, and the result is the output. Okay, look at here. The condition actually is a fix. Okay. However, for the product design, conceptual product design, okay, so we know input and we know our output. Okay. So this one is a conceptual product design. Okay. So the outcome is actually is the modeling. Okay. Outcome of the modeling is the material type, amount, and also configuration. This one you can do based on the kinetic, transport process, thermodynamic, and also material science. Okay. So this is the difference between product design and also product analysis. Okay. So you can read here. Okay. Yeah. So we can do this one actually by using the mathematical modeling. So what is the mathematical modelings in science and also engineering? So if you look at here that representations in terms of behavior of real devices and also of object. Actually, we have a real phenomena, right? Okay, this is real also, the consumer. So the conceptual worlds based on the observations, we do the model prediction so that we can meet the real world phenomena. This one. So engineers need to model products and process to design and fabricate this product and process that have not yet come to life. Okay. So we have to concept by using the modelings. Okay. Before we release to the real world. Okay. Any questions about this one? Okay. Okay, what is the mathematical modeling? As I told you, like if you want to design like what is it? Heat flow and heat release, right? So what you need is like a equation of uh, heat flow, heat ins, okay, Fourier law, viscosity. Okay, that is the mathematical modeling. Okay, the example. So this is an example of the mathematical modelings. Conservation principle, right? Q represent as a mass, momentum, and energy. Is a mass and energy balance. Okay, Q in, Q out. Right, this is a mathematical modeling. Okay, like Fick's law, Fourier's law of viscosity. If you want to design, I think if you want to design what air purifier, right? Okay, what equation that you need to use? Okay, and then you want to what is it in term of the catalyst, right? Okay, what the equation that you use? Okay, is it a kinetics? Okay, okay, and then reaction kinetics. Okay, in to meet the product specifications. Okay, that's you have to import. That is important lah. Okay. Similarly, also if you want to design the what is it the functional products lah. Okay. So you need the physical chemical properties. Okay. To identify the product specifications. Okay. That's all the mathematical modeling is important. Okay. Okay, any questions about the mathematical modeling? This one I will not explain. This one we will use. This one just example, and we will use in detail in designing the chemical devices and also formulated product. Okay. Okay. Models actually have a different degree of complexity. They have a, we can divide it into three lah. Okay, three models. Okay, if you want to use these modelings. Okay, actually it can be differentiated depending on the complexity and also accuracy. Okay, simplest one is the black box models. Okay, second one is simplified models. Maybe not very accurate, but black box models that have also limitations. Okay, sometimes it's poorly understood. Okay, experimental effort maybe because it's a very simple, right? Simplest models, right? So we need the extensive of the experimental. We need to do the more experiments because it's just a simplest model. Okay, and then we have a rigorous model. Okay, rigorous models is uh, this one is a more details, completely understood. Okay, we have a detailed analysis of the phenomena as compared to the simplified models and also black box models. Okay, so it's depend on you lah, which one you want to choose. Okay, if you want to more is it more details, you can use the rigorous models. Okay, but in black box models is maybe the experimental part is what is it you need to do more extensive. Okay, but simplified model maybe the experiment part is very not really extensive as compared to black models. Okay, for the rigorous maybe sometimes you need the what is it experiment, and to confirm again maybe you require the experiment. Okay, as comparison, if you look at here that the approach, right? Okay, black box models, simplified models, and also rigorous models. Also the technique is more to the data fittings, right? And then simplified. This one is detail. Yeah, the comparison. Look at here that fully understand, partially, and completely understood because it's in details, rigorous model. Look at here another example. Another difference is at extensive experimental effort. Okay, maybe need verification or no verification. This one is maybe verification is very minimal. Okay, so that is the difference. Okay. Okay, so in product design frameworks for the executions, okay, first you have to know the methods. Okay, the rule based, model based, right? Okay, what's method that you want to use? Okay, maybe you need the mechanistic model, hybrid models. Okay, and some database. Database is important. You want how to collect database, you refer back to the previous chapter, right? Maybe you need the chemical database, okay, equipment database, thermodynamics. Okay, tools, you need the software. Okay, if you want to execute your task, right? Okay, you need the tools. What else? MATLAB, ICAS, ASP.NICE. ASP.NICE I think is for the apa is it, for the project chemical design, right? And then also some experiments for the verification. It's depending on the approach that you want to use. Okay, which model? If rigorous, maybe very minimals of the verification by using the experiments. So this is the element that you need in for the execution of the task. Okay, as a framework. Okay, method, database, tools, and also experiment. Okay, any questions before we stop? It's just introductions. Okay, the main part is this one. How can we design the chemical device and also functional products? I hope that you can read. Yes, it's just a general knowledge about the chemical device. Okay, functional product and also formulated products.